Let's talk about thermochemistry. Nearly all chemical reactions involve either the release or the absorption of heat, which is one form of energy. Heat is involved in reactions by either going into or out of the reaction system, and is one aspect of reaction that can be monitored. Thermochemistry is the study of the energy effects that accompany chemical reactions. Why do chemical reactions occur? What is the driving force of a reaction? Well, the answer is stability. Reaction wants to get to low energy. For a reaction to take place spontaneously, the products of the reaction must be more stable at a lower energy than the starting reactants. A non-spontaneous reaction means the reaction will never happen by itself. The reaction can happen, but it will need some external help to make it happen. Reactants that are higher energy or less stable, therefore more reactive. The reaction itself releases energy to go from a higher energy level to a lower energy level, therefore the reaction is spontaneous. If the reactions are at lower energy, then they are more stable and less reactive. To go from a low energy to a higher energy, the reaction must absorb energy from some external source. Therefore, the reaction is non-spontaneous. It will need help from outside to make the reaction happen. Energy is defined as the capacity to move matter, to do work. The concept of energy gives us an alternative way to describe motion. There are three broad concepts of energy. First, kinetic energy is the energy associated with an object by virtue of its motion. Potential energy is the energy of an object by virtue of its position in the field of energy. And internal energy, using the symbol U, is the sum of the kinetic and potential energy of the particles making up the substance. The total energy of the system is the sum of its kinetic energy, its potential energy, and its internal energy. So E total is equal to EK, EP, plus U. However, typically in a laboratory, the experimental vessel is at rest, making the kinetic and potential energies contributions to the total energy zero. So we tend to neglect them. So your total energy is equal to your internal energy. The law of conservation of energy states the energy may be converted from one form to another, but the total quantities of the energy remain constant. Energy may be transferred or converted, but not destroyed. In chemical reactions, heat is often transferred from the system or reaction to the surroundings, or vice versa. So let's define the system. The system is the substance or mixture of substances under study in which a change occurs, your reaction that you're looking at. The surroundings are everything else in the vicinity of the thermodynamic system. It could be the room, the flask, the solvent, etc. So in essence, we have our system. In essence, we have our system or reaction, and then we have our surroundings around. We tend to measure the change in internal energy of a system. We need to keep track of what's going into and out of the system. So things that are going into the system give a positive value. Those things going out of the system have a negative value. So the sign plus or minus for energy indicates the direction of flow, meaning into or out of the system. Heat flow is defined as the energy that flows into or out of a system. We follow heat flow by watching the difference in temperature between the system and its surroundings. Often we follow the surroundings temperature, meaning the solvent, and must realize that the opposite is happening to the system. If the system is absorbing heat from the surroundings, then the temperature of the surroundings must be decreasing. So it's inversely proportional. If the temperature of the system is increasing, meaning a positive value, then the temperature of your surroundings must be decreasing, meaning the negative value. Heat flow, or heat of the reaction, is denoted by the symbol Q, and is the amount of heat required to return a system to a given temperature at the completion of the reaction. For an endothermic reaction, the sign of Q is positive. Heat is absorbed by the system from the surroundings. So delta Q is greater than 0, meaning it's taking on heat. So you have a positive Q going into the system in the endothermic process. So the temperature of the surrounding is going down. So the temperature of your system is going up. So your internal energy is going up. The system absorbs heat from the surroundings. So this is a non-spontaneous reaction. To go from a lower energy level to a higher, it's going to have to take on energy from somewhere else, which is the surroundings giving it. For an exothermic reaction, the sign of Q is negative. Heat is evolved or released by the system to the surroundings. So your delta Q is less than 0. The heat is coming out of the system and going to the surroundings, so we have a negative heat. Your temperature of your system is going down, so the temperature of your internal energy is going down. The temperature of the surrounding is increasing. The reactants are going from a higher energy level to a lower energy level, therefore you're releasing energy to make that happen, therefore this is a spontaneous reaction. Homework 50.